The next section we will be covering is questions 4 to 6. On the previous slide, you should have seen this math term that says, a scatter plot displays the relationship between two sets of numerical data. It can also reveal trends in data. Number 4, graph the data in your table from item 2 as a scatter plot on the coordinate grid. All right, now in order to graph this graph is not going to do me any good because my number of students went all the way out to 20, but my time only goes up to 10 seconds. And if you recall my data, it was bigger than 10 seconds. So what I'm actually going to do is I'm going to change my time to go by twos. So this is going to be 2, 4, 6, 8, 10, 12, we're going to have 14, 16, 18, and 20. That way all my data will be able to fit in there. So at 3 students, my data was 4 seconds. So we're going to go over to 3 students and go up to 4 seconds. I'm going to place a dot there. Then I have 6 students for 9 seconds. 6 students, this is 4, 6, 8, 9 is going to be at that halfway mark. So we need to put it halfway between 8 and 10. Then we've got 9 students for 11 seconds. So this was 10, this would be 11. Okay, we've got 11 students was 14 seconds. So let's see. This is 11. That's going to be 12, 14. There we go. At 13 students, it took us 17 seconds. So 4, 8, 10, 12, 14, 16, 17. Right there. And for 15 students, it's going to take us 19 seconds. Well, if this is 13, we'll go 14, 15. Right about there. All right. Are the data that you collected linear data? And explain your answer using the scatter plot. And then we're going to explain our answer using the table of data. Now remember, linear means that it increases by the same amount each time. Well, this isn't technically linear. I mean, if I graphed a line here, it's not necessarily going to be straight. I mean, because we kind of jump up here, kind of decrease here. From here, it kind of looks a little linear-ish, but not all the way. Okay. So, using my scatter plot, the points like close to a straight line, but not on a straight line. So, I mean, it looks linear, but like I said, it's not an exact straight line. All right, if I used my table, now remember this was my table. I had 3 was at 4, 6 was at 9, 9 was 11, 11 took 14 seconds, 13 students took 17 seconds, 15 students took 19. Remember that in order for us to use a table, if it's linear, that rate of change should always be the same. So I could do, looking at the point 3, 4 and the point 6, 9, I could call this x1, y1. x2, y2. And I could use that slope formula. If you recall the slope formula, it was m equals y2 minus y1 over x2 minus x1. So we can use the slope formula here, and we could say 9 minus 4 over 6 minus 3. Well, that's going to be 5/3, right? Let's look at another 2 points on the line. We have 13, 17, and let's go with 15, 19. Again, we're going to call this x1, y1, x2, y2. So this time I'm going to do 19 minus 17 over 15 minus 13. Well, that's going to be 2 over 2, which is 1. Let me use another 2 points on the data points. Let's do that 11, 14. And we'll do 9, 11. So we're going to have 3 over 2. Well, can anybody tell me what 5/3 is? I believe that's 1.6 repeated, right? And 3 over 2 is 1.5. So they all lie somewhere between that 1 and 1.6, but not all the same exact number. Okay, let me ask you this. How does the time to pass the book change as the number of students increases? What do we notice? As we add more students to the row, what happens to the length of time? Yeah. As the number of students increases, the length of time also increases. We can see that in the graph. As it gets higher this way, my time goes up. So this line is what we call positive, has a positive slope. As one gets bigger, the other gets bigger. Let's go on to the debriefing for this section.